Now, before we begin, let me share with you how the Gov Cloud series came about. In recent years, organizations are leveraging various technologies to improve their business operations, from cloud computing to artificial intelligence, and of course, for the public sector, this is no exception. So as a company focusing on digital government transformation, Topan & Currer has helped various government agencies transform their operations from migrating their systems onto the cloud to implementing data-driven solutions using machine learning and AI techniques. Now, along the way, we picked up some learning points that we thought you could benefit the industry. So here we are. We put together a series of Gov Cloud webinars to share ideas, and hopefully this will be beneficial to you. In our first 2 episodes, we focus on topics related to government compliance solutions on the public cloud. In the first episode, we spoke about how content inspection should be an important feature of API gateways designed for government systems. The second episode was on DevSecOps and its different stages for governments on the public cloud. In our third episode, it was a feature on text analytics and computer vision, essentially how AI and machine learning can be applied. So for our fourth episode, we decided to share about architecture. Okay, let's do a quick time check. It is about 1:02 p.m. Seems like most of our attendees are in. I think we can carry on and start the webinar. So hi everyone, welcome to the fourth episode of our Gov Cloud webinar series, Event-Driven versus RESTful Microservices, Why It Matters. My name is Mark. I will be the host for today, and together with me, we have Darren and Anson.
Hello.
So that's Darren and Anson. Hi. Okay, let me just talk about a few words about Darren and Anson. Darren, he is our lead solution architect covering products as well as overseeing our solution architects in delivering digital government systems. He is also our technology evangelist, working closely with our CTO to keep up with industry trends and identifying key technologies that can be applied in digital government. Now, Anson is one of those experienced architects. He has been in the trenches architecting various systems for government. Now, he works very closely with Darren on applying the right microservices strategy for the projects that we do. He has passion in applying new technologies and new architectures to reap benefits for you, the business users. Now, I guess everyone should be quite excited to the start of the content of this webinar. But before we begin, I would just like to remind everyone there's a little bit housekeeping rules. This is a live webinar. We are recording this session, and we will be releasing this onto our YouTube channel. So after this session, do head over to YouTube, search Topan & Currer, and you can find our channel. Make sure you subscribe to our channel and give us a big thumbs up. Also, we are open to questions during the presentation. Please do pop them into the Q&A box. The Q&A tab can be found at the bottom of the webinar screen. Lastly, if you wish to invite us to present to your team or colleagues who can't make it for this session today, or you have other questions regarding this session, do drop a note to info@topan@currer.com. Now, without further ado, I will turn over the time to Darren. Darren.
Good afternoon. Welcome to our Gov Cloud webinar, and thanks for being with us today. So today's topic consists of 2 parts. In the first part, I will be covering the concepts about event-driven and how events are very much in our daily lives in the world that we live in, and why it really matters to us. Then I will pass on to Anson to walk through with you an example of a government use case and compare the different approaches and the benefits that you can reap. This will be followed by a Q&A session, but please feel free to drop your questions in the chat window anytime so that we can pick them up later. And the whole session should wrap up within the hour. So let me start by explaining why we are here today. Well, we have been in the government IT business for the past 22 years to be exact. I guess what makes us different from other government IT vendors is that other than focusing on delivering government systems, we are also constantly looking at industry trends for new ways or relevant technologies that can be applied to government systems to help deliver towards its vision of becoming a smart nation through digital transformation. 3 years ago, when the government digital transformation was still at its very early stage, we have been talking about microservices, among other things, that as part of the digital transformation strategy. And we are going around also pitching and sharing to agencies about its benefits and how it can help deliver towards the government's vision. So fast forward to now, today, we are seeing government systems are increasingly adopting the microservices architecture. And most government tenders we see today are actually specifying microservices as a requirement. So this is no longer an option. It's becoming the new normal. But are we doing enough in terms of digital transformation? Let's say after having implemented microservices, after having moved to the cloud, implemented CI/CD and so on. So in short, we think we are not, if we are missing out on this one key important element, which is events. So having successfully delivered several microservices for the government, we are not standing still, and we continue to look for new ways to do things better, drawing on lessons we learned from the past. So today we will be discussing an event-driven approach for implementing microservices and how it can bring about the true benefits of a microservices architecture. And most importantly, how having such an event-driven architecture in place can help your organization achieve greater benefits, not just technical implementation approach, but also in terms of delivering new value services to the users, to your public. Just to keep you guys informed, this will be the first episode of the series of topics focusing on event-driven systems. So we are working on upcoming topics to talk about how we can further leverage this event stream to deliver greater impact. Yeah, so stay tuned for our updates. So before we proceed, I need your help here to take a quick poll to help us understand how you are building your systems. Whether is it a monolithic approach, or is it a RESTful microservices, or maybe you are one of more adventurous that have already taken the plunge to implement event-driven systems. Do let us know. So if you have a combination of this, please just take the most recent one or the ones that you are currently working on, or the one that you feel is more relevant. So please help us to take the poll. So let me proceed. So I'm going to cover this part, the first part of the topic, which is something called the event-driven world, and why is there a need for event-driven systems? Okay. So the world that we live in is actually a continuous stream of events, whether it is arising from people-to-people interaction, or between people and organizations, or even nature. So what we see today is that businesses are increasingly moving from a periodic batch processing system to a continuous event stream processing system to deliver real-time results. So no longer are we looking at daily or even hourly updates or even minutes, but rather updates coming in a real-time and continuous fashion. That is what we experience in the services that we interact with today. So we just need to look at those services that we are using, for example, Google, Facebook, or favorite services that you're using, and those modern digital business that we interact with on a day-to-day basis. And I don't have to even show you a Gartner chart or some research paper to prove to you that this is very real. So let's take a look at some real-world examples of such a real-time business. Okay, the first one I'm going to talk about is LinkedIn. So I believe most of us here are professionals. We are on LinkedIn. So LinkedIn has something like more than 600 million registered users with about 40% active users. So that's roughly about 250 million active users every day. So the news feed that you see when you're accessing your LinkedIn, whether through your app or on a website, are actually dynamically generated in real time and customized to individuals. Everyone logged into their LinkedIn will see a different news feed that is customized to himself or herself. So it consists of updates from your network, such as your connections, the companies or topics that you follow, and maybe some recommendations or maybe some sponsored contents and all that. and it is sorted by relevancy and it's generated on the fly. So LinkedIn is one of the early adopters that has an event streaming architecture that actually today handles more than 7 trillion messages a day. So how amazing is that? And it's processing in real time. So the next example we are going to talk about is Uber. So I believe most of you are familiar with Uber. So Uber is actually a ride-hauling business that handles more than 10 million trips a day. So when you open your Uber app and you request for a car, it is actually tracking your live location along with other data such as traffic, your ratings and whatever. And it is doing real-time matching with cars within your vicinity. So when a ride has been matched, it is also able to update you about the real-time location of the cars that is coming to you, as well as providing you real-time ETA. So how long do you expect to wait? On top of that, it is also constantly tracking and monitoring demand and versus supply, and computing whether a price surge is necessary when demand in a particular area exceeds the supply, such as during peak hours or maybe at the end of some major events. So there's sudden surge in demand. So it is actually monitoring that in real time and applying some price surge algorithm. So this has been proven to effectively ease the supply and demand imbalance, as some customers may choose a different timing or maybe take a different mode of transport, and drivers are encouraged to move towards the high demand areas. So this is applying technology at its best. So in short, technologies actually exist today to deliver these real-time capabilities as proven by these leading digital companies of the world. Okay, so what are events? So events are actually the heartbeat of an organization. So they represent the activities and interactions that actually defines your user and organizational behavior. Basically, it describes everything about your business. So in a typical government business, these are the events that you see on the daily basis. Somebody apply for a license, you issue a license to the user, and sometimes they renew license and all that. Yeah, so these are the events that goes through a typical government organization. So it defines, basically, as I said, it defines what your business is all about. But are we actually leveraging on this event stream? So let's take a look at how we actually build systems. So most systems today that we build is based on a relational database approach. So a relational database is actually designed to capture and operate based on the most current state. So you have events streaming coming to your system on the daily basis, and eventually it gets stored as a state in the database, which is the one that you operate on. And when there's new events that come and change the state of your current state, or let's say the state changes due to some whatever reason, so your past events now exist as a audit trail or history in the database. So new events come and change your state, and the old events gets pushed to a history or audit trail. That's typically how we build systems today. And the focus on the system is actually operating on the most current state. So to help you see the difference between event versus state and what is history, let me give an example of an illustration. So basically, events flowing through a system are captured as a current state in the database. So for example, let's say somebody submits an application. It goes to a database as an application record with a status. Maybe it's a new status because it's something that is just submitted. And maybe sometime down the road, the application is amended. So the state changed to amended. So now the previous status gets pushed into history. And it keeps going on. So every time you just keep track of the most latest state, and the rest gets pushed down to history. And the history is actually the stream of events that goes through your system, but it's often discarded as it's just a history that we don't typically work on. So that's how we build current systems. So let's look at in the microservices architecture, how these events are being handled. Where are these events and how they are being handled? So as we know, microservices actually represents a bounded context or business domain. You can think of it like your departments within an organization or maybe some user groups. So you have a system consisting of many microservices. Let's take an example of 2 microservices. So messages that you pass between your microservices are actually events that represent the behavior in the system. So it can be an event coming from external user, or it can be an event that is generated internally within our system. So what you pass between microservices are actually events. And today, when we build microservices using REST API, this is how we pass messages between microservices. We basically pass them over the network as a REST API call. But the problem is that the events are actually transient over the network. And at the end of the call, only the 2 participating services know about this event. So what happens is this event is also relevant to some other services. So one thing you can do is that you change your service A, which is calling service B, you change it to implement another REST API call to the new service. But as you can see, this quickly gets into a messy situation when you have more and more microservices, and they all need to know about each other's event, and you have a lot of this point-to-point integration across the microservices. So it kind of creates a very tight coupling effect. And one thing you also note that when one service calls the other service, the other service has to be up at the time of the call, because it's a synchronous call over the network. So later we will see some more in-depth analysis on this. So how do event systems actually work? So what if instead of calling over the network, we have a platform that can stream and capture these events permanently? So your service that produces the event actually now publish the event into the streaming platform, and it can keep on publishing, and the service that is interested in the event, service B in this example, can just consume the event of the so-called event streaming platform. So it can consume the event in the real-time manner as and when the event come in, or maybe it can consume sometime later when maybe when it's up to handle the request. So the events are actually buffered in the event streaming platform. So using this approach, microservices are more loosely coupled. And at the same time, when you build a system based on this approach, you also create an event stream that is shared across all the microservices. Remember, we say that events are the heartbeat of the organization. So everything that goes through external, whether it comes from external or any event that is generated within your system, now gets into this event stream that is now being shared across all the microservices. So when you have a new service that requires to consume the same event, what it needs to do is just tap on the event stream. So there's not even the need to contact the team, talk to the team that implements service A to say that I now need your event. So you just basically tap on the stream. So with this in place, new services can now plug in and tap on the event stream at any time. So business can add new capabilities easily. So one classic example is that because events there's a lot of insights about your business and your everyday activity in your event stream. So you can plug in analytics, real-time analytics that actually processes and derives some insights from your event stream in a real-time manner. Because once it gets plugged into the event stream, new events will straight away get pushed to the service, and you can do real-time analytics, as opposed to what you're doing now, which is typically post analytics. And maybe after running a system for some time, you may have better understanding of our system, and maybe some policies there's some loopholes or whatever that people can exploit, or there's maybe some holes in your system that somebody can try to exploit. Maybe you're a grant system or what. So you can plug in new algorithms that you will better understand your system to do some fraud detection, and this can be added later, because once you plug in the event stream, this event stream is going to store the history of all your business events. So once you plug in, you can actually even retroactively comb through the events from the past and also in the real-time manner. You can also do things like alerts and notification service that you can plug in to listen to your events and generate alerts as and when it's necessary. For example, let's say when an application is approved, you want to notify your users, or when the fraud detection is being detected, possible fraud is being detected, you can also use it to alert your staff and all that. So all these are easily added. One last important example I want to give in terms of what you can do with it is something called the stream processing. So this is about real-time processing of events as and when they come in, and you can, using this approach, you can actually derive new benefits and new possible features in your system that you can never do before. So I will cover more of this in the next slide. So, but in general, event-driven microservices are more independent, scalable, and resilient. Later, when Anson's part, he will actually share more detail on each aspect of this. So before let's talk about event stream processing. Okay, let's say you have this event streaming platform in place. So you can do things like you can combine streams from different sources to in real time and to deliver some services. For example, this example is actually a real-time flood warning system. So imagine you have a water sensors throughout the island in your drainage system, detecting the water level in the drainage, and you pump this stream of data into your event stream. And you have interested subscribers that wants to know when there's a potential of flood. They subscribe to your service. So maybe they open up the app and they start streaming their real-time location into your event stream. So what you need to do is that you have a stream processor that actually process this two stream of events as and when they are coming in, and maybe do some filtering, check if the water level is greater than 90% and there's a chance of flood, and it will do a real-time matching in terms of the sensor and the subscriber location, and it will pump out into a stream of subscribers who are within the vicinity of high water levels. Then you have an alert service that actually tap on this stream to send out warnings to your subscriber, and all this in a very real-time manner. So no longer are we looking at batch processing systems. So today's focus will be on event-driven microservices, how you're going to implement them, your microservices in the event-driven approach. So some of these advanced features we will be covering more in the future topics that just now I briefly talked about. So just bear in mind that these are the new possibilities that you can have once you start getting your event stream architecture in place. Okay, so before I pass the session over to Anson to talk about the event-driven use case for the government, let me just quickly, because there's one question that I saw in the chat that I thought is relevant that I cover it here. So let me read out the question. So what kind of platform do we need for event-driven? So is it like an MQ system? So my answer to that would be, a traditional MQ system is actually designed based on the philosophies and architecture from the SOA era, where orchestration is centrally managed at the ESB platform. So it's based on the concept of queues and message routing. And this is what is known as dumb endpoints and smart pipes. As compared to the modern day shift, it's actually shifting towards smart endpoints and dumb pipes. So what we are proposing is an event streaming platform that is capable of not just of persisting events that live beyond the life of just passing message between two microservices. We are also looking at a platform that can do real-time stream processing, which is not what a MQ system is designed for. So if we are looking purely at event-driven systems as an implementation approach, where we need what we need is just an intermediate messaging platform to route these events. Then maybe you can think of using an MQ system, which is suited for that purpose. But if you are looking beyond this, we want to create an enterprise-wide event stream architecture to achieve the benefits that we just talked about. We need to look beyond an MQ system. I hope that more or less address your question. Okay, with that, I will pass to Anson to cover the second half of the webinar, the presentation. Over to you, Anson.
Okay, thank you, Darren. Good afternoon, everyone. So what I'm going to do next in the next 20 minutes is that I'm going to share with you one simple use case. And with it, I'll first show you a microservice architecture design that's based on REST as a service-to-service communication. And then next, I'm going to compare that with a microservice design that's actually based on events for service-to-service communications. Then we will see what's the difference between these two approaches itself. While we go through, I'll also highlight some of the challenges that you may face when using REST for the service communications and how an event-driven approach can better handle the issues. This will help you understand how an event-based microservice architectures can help you achieve the true benefits of microservices. So let's begin. All right, so let's imagine you are building a one-stop grant portal, which will be providing a systems where applicants can actually apply for multiple types of grant within one application. Each grants may be processed by different departments, and when the grant application is approved, the finance department will handle the disbursement of the grants. Right. So let's take a look at how we can potentially design such a system using microservice architecture. Let's first take a look at the design based on REST for its service communications. There's a grant application service to provide online application functionalities to the applicant. There will be a service for each types of grants, right? There's also a disbursement service that will handle the grant disbursement after the grant is approved. Each service will have their own persistent data store to store their own data. And each service also has will also expose their REST APIs to integrate for integration with other services. When an applicant submits applications, they submit their applications through the grant application service. And depending on the type of grants is applied, the grant application service may integrate with the respective grant services to create the relevant grant applications. For example, if the applicant applies for all three types of grant, the grant application service will call the REST APIs of the respective services. And once the application is processed, the respective grant service will then call the disbursement service REST API to process the disbursement. These are simple scenarios how a grant application system will be designed using microservice architectures and communicating with each other through REST API. Let's take a look at what are some of the challenges that we may encounter with this design. Let's go through the flow again. Imagine an applicant submits an application for all three grants through a grant application service. So when a grant application service receives the applications, you will try to communicate with all the three grant services to create the relevant applications. So it first calls the grant A services through REST API and successfully creates a grant A application in grant A service. Next, it calls grant B service through REST API again, and let's say it also successfully creates grant B application in grant B service. However, imagine what will happen if grant C service is down at the point of application submission. The REST natures of being synchronous means it will cause the applications to fail. And the applicants will actually encounter errors and during their application submission in this case, causing the whole application to fail. From these scenarios, you can see that one of the challenges of microservice communicating through REST is that it's intolerant to service downtime. And failure in one service may potentially impact the overall operation and bring down the whole systems, thus negating the benefits of microservices for being resilient. Another challenge that comes with this scenario is the data integrities. As I mentioned earlier, each service has their own persistent data store to store their own data. In these scenarios, the grant application service has created application records in both grant A service and grant B service. So when grant C service fails, it actually causes the whole application to fail. So now there's a need to actually roll back this data in the grant A service database and the grant B service data store, right? In a traditional monolithic applications, we have ACID to ensure that, or even if you are spanning across a different database, there are techniques such as two-phase commits to ensure the atomicity of the transaction and the integrity of the data. However, those safety nets do not apply in this scenario, as each service is responsible for their own data store. There's no such thing as two-phase commit, right? So how do we handle in this kind of distributed database scenarios? Typically, you need to implement compensations REST API. For example, if you have an API to create applications, you also need to provide an API to delete applications. So in this case, to roll back, the grant application service will need to actually cause the delete applications APIs in the respective grant A and grant B services. This approach looks simple and straightforward when we are talking about 2 or 3 services. However, in real world, it's always not so simple. It is common for one service to call 4 or 5 services, and worse still, there may be multi-level nested APIs. For example, service A may call service B, and service B may call service C, so on and so forth. So in those scenarios, we not only need to compensate service B, but also need to compensate the downstream of service B, in this case, service C. This further increases the complexities of doing compensation itself. And this approach is also not very reliable. Imagine that grant A service went down when grant application service tried to call the compensation API. In these scenarios, your data will become inconsistent because you will not be able to roll back the application A records that you have previously created. So to handle this, we also need to do periodic reconciliations to ensure that the data is consistent across the distributed persistent store. Right. So through these scenarios, we see another challenge of REST-based microservice implementation, which is the challenge of keeping the data consistent. As I shared with you, the complexity of ensuring the data consistency, as well as the high chance of failures during data compensations, will easily result in data consistency. The next challenge that I'm going to share with you is this. When you read about microservices, they give you this promise. Independent services can release whenever they want, they are fast, they can break things. However, what happens in the real world? Let's say the team handling grant C services may have provided some enhancement to their service, and they want to do a deployment today. So often of the time you see things like, for example, the grant application service will tell you that you can't bring down your services within this 2 critical period, right? Because I need to make sure that within these 2 weeks, all the applications must be able to have to go through successfully, and there shouldn't be any failures. Sounds familiar? We can't help but ask ourselves why. Right. Let's dive in more details to help us understand why. In a REST-based implementation, service communicates with one another through API. Right? So for example, the grant application service, when they want to actually integrate with grant C service, they may actually go through a post API with 2 JSON attributes, for example, an applicant names and the grant type. So in version 1, this integration works fine, right? However, let's say grant C service is going to upgrade to version 2. And as part of the upgrades, there's a change that requires the API to pass in a mandatory attribute called apply application reason. Once upgraded to version 2, the grant application service, the API calls will fail as it does not provide these mandatory fields called application reason. And this, in terms, will actually cause the whole application to fail. Right? So through these scenarios, we can see that the REST-based microservices creates tight coupling between services. When downstream services need to make changes, they need to ensure that the changes either do not impact the upstream services or it must be backward compatible. However, oftentimes developer will say changes have no impact, but when the changes got deployed into the productions, that's when we started to see error pages here and there. It is common. So in order to reduce such risks, too often we'll just say, don't touch the system in this period. Right? Wait until 2 weeks later, right? Or wait until it's not so critical, then you can do the deployment. So therefore, the third challenge that we see here of using REST for service-to-service communication is that it causes tight coupling between services, and it makes it difficult to make changes without causing impact on other services. Right. The next challenge I'm going to share with you is regarding scalability. One of the promises of microservice is its ability to independently scale. But is it true in this design? Let's imagine if there's a sudden influx of Grumpy applications. Being microservice design, we'll try to say, okay, you can scale up Grumpy service, right? But will that solve the problem? When we scale the Grumpy services, it should be able to process more Grumpy applications. However, the Grumpy service has a downstream dependency on the disbursement service. Due to this dependency, now the disbursement service itself has become the very bottleneck. So in order to truly scale up Grumpy service, you not only need to scale up the Grumpy service itself, but also have to scale up its downstream services, so as not to create the bottleneck. From this, what we can observe is that the REST-based microservice implementation approach creates tight coupling between the services that hinders the service to scale out independently. And often, you will need to actually scale all the dependent services in order not to create a bottleneck. I'm going to share with you one last challenge before we zoom into the event-driven design. One of the major benefits of microservice is that it increases your business agility, right? Where you can quickly create new functionalities, you can quickly deploy new features. Let's examine if, let's say, that's the case in this design. Imagine now your stakeholders tells you that you need to actually send out SMS to applicants once their grant is approved or rejected. As an architect for the system, I'll say, okay, let's create another service called notification service. This notification service will be responsible for sending SMS. Great. Next comes the question. So how does my notification service know what to send out? Never mind. I'll expose the send SMS function as a REST API. Right. So whichever service that needs to send SMS can call my REST API. Right. So in this case, I'll have to modify the grant A, grant B, grant C service. They need to send SMS, they will just call my REST API. That makes sense, right? But think about it. Now, to implement this, I not only need to create a new service, I also need to make changes to the existing services. So when we need to roll out these new features, there's a need to coordinate between the services to be able to do the rollout together. Because imagine if, let's say now I've rolled out the grant A services without growing out the notification services, the grant A services will fail because now the downstream REST APIs is not available. So through this, we can see that it's not easy to introduce new functionalities or new features, as it often requires changes to the existing services. I've shared quite a few challenges of using REST as a service-to-service communications. And with those in mind, let's examine how the same systems can be implemented using event-driven approach and how using events can solve some of those problems that I've highlighted earlier. In the event-based microservice design, similar to REST-based, we have cut the functionalities into individual service. It's the same sets of services that you see early on. where you have a grant application service to receive the applications. You have the multiple services, grant A, grant B, grant C service to process individual different types of grants, and the disbursement service to actually handle the disbursement. And similarly, each of their service will actually have their own data persistence stock. What's different in this design is that instead of communicating through REST, all services communicate through a common pipe, which we call event stream. Let's see how it works when an applicant submits applications. When an applicant submits applications, they submit their applications through the grant application service. Upon receiving the application, the grant application service stores the application in its own database and emits an event to the event stream that the application records receive. Right? And it may also contain details such as what are the grants that it applies. Grant application service will then respond back to the applicant that application submission is successful, and then that's all for the applicant side. Right? The events in the event stream will then be picked up by the relevant grant services for further processing. In this example, as the applicant has submits for all three, it will be picked up by all the three services. If the applicant only submits for one, the applications will only be picked up by a relevant service. Next, each grant service will then process and then approve or reject the grants. So similarly, they will emit the approval or rejection events to the event stream. And these events will then be picked up by the disbursement service to handle the disbursement, right? And the disbursement service, depending on the business requirements, may only pick up events that it's interested. For example, they only pick up grants that's approved. And similarly, when a grant is disbursed, they may also emit back an event to the event stream. This is a sample of how the same grant system can be implemented using event-driven approach. Let's see how this design handles the challenges that are highlighted for the REST implementation. Earlier, I highlighted a scenario where grant C service went down when the applicant makes an application, and that causes two issues in the REST implementations. Number one, it causes the whole application to fail due to intolerance to failure. And number two, the data integrity issues, particularly on how to roll back transactions that span across services. So let's see how this works in these scenarios. Applicant makes a submission through grant application service. The service actually accepts the applications, and the applicant will be able to successfully make the submissions, even when grant C service is down. The grant application service emits an event to the event stream. Right? And these events will be picked up by the remaining healthy services, in this case, the grant A, grant B. Right? And they can even proceed to process applications without waiting for grant C. They may even proceed to go down to disburse the grants if the business allows it, right? Even if grant C is unavailable. When grant C recovers from its service failure, you'll pick up what it needs to process from the event stream and continue its process. From this example, we see how an event-based microservices increases the resiliencies of the system. Faults are isolated within each service, so when there's a fault in one service, it does not impact the operations of other services. And most importantly, when the service recovers, it's able to resume from where it stopped. How about the data consistency part? For this example, we see that the grant application received is persisted into the event stream even when the grant C service was down. And when grant C service recovers, it picks up from the data from the event stream. So there's no data loss. And there's no need for the complex compensations or reconciliations that are shared with using the REST implementation earlier. This makes it easier to maintain the data consistency. Let's examine the next challenge that I shared with REST implementation earlier. Earlier, I shared that one of the challenges of using REST implementation approach is that it hinders the independent services to release or upgrade whenever they want due to the risk of tight coupling. In the event-based microservices design, services communicate indirectly with one another through event stream. There's no direct service-to-service communication. So in the event that if the team that handles Grant C accidentally introduce a bug or defects in the Grant C services in their new version, it does not impact other services. You can still continue to accept the applications, and other grants services may still proceed to process their applications. Right? And when the team recovers the service, it will pick up from where it stopped. With this design, faults are truly isolated. Hence, it provides the confidence for the developers as well as stakeholders to allow each service to independently deploy, upgrade, you can even start or stop without affecting other services, thus providing the true autonomy for each service. In this slide, I'm going to discuss about the topic of scalability. Earlier in the REST implementations, I shared that we can't truly scale out a service independently due to there's dependencies on the downstream services. If there are certain grants that have more application than others, we can scale out that particular services, right? So what happened is that once the grant B service processes its application, you simply emit the events to the event stream. The disbursement service will then pick up these events from the event stream for processing. Right? So there's no direct dependencies on the disbursement service that will create bottleneck. With this design, each service can be independently scaled as needed to meet business demands. Lastly, I'm going to talk about these topics on business agilities. Right? Earlier in the REST implementation, I shared that it's not as easy to introduce a new functionalities or new features, as it often requires changes to the existing service. Let's examine that problem if we still have it in this event-based design. We'll use the same scenarios where stakeholders wanted an SMS to be sent out when a grant is approved or rejected. So similarly, we'll create a notification service. However, we do not need each of the grant service to make changes to call the notification service. Instead, the notification service will just plug itself into the event streams to pull out the relevant events. So for example, you'll pick up all the grants approved or rejected events and do the necessary sending of SMS. As you can see from this example, we can easily extend new functionality or features without having to change or affect the existing service. And this allows business to evolve and build new features easily. Right, so to summarize some of the points that I went through earlier, so event-driven microservice implementation approach provides, number one, the better resiliencies, where faults are isolated within each services. So when there's a fault in one service, it does not impact the operation of other service. It's better handling of data consistency in a distributed database as compared to REST, which requires compensation and reconciliation. This loose coupling provides autonomy and confidence for each service to upgrade or enhance without impacting other services. It also provides better scalability that allows each service to truly scale independently. And last but not least, as demonstrated earlier, is how it provides business agilities on how easy is it to build new services and plug in without having to change other services. Sorry. So now, after all I have shared, you may ask, does that mean that we need to move to event-based for our microservice implementation? We think that there's no one size that fits all. There are scenarios where one approach is better than the others. For example, if you are building front-end services that will be consumed by web or mobile applications, we think that REST API synchronous approach is a natural choice. If you are building APIs integration with external systems or external services, right? Again, I think REST is fine. If you're trying to build service-to-service communications that is not time-sensitive and do not require immediate response, in this case, we think the event-driven is a better choice to provide the loosely coupled design of the microservices. And if you're trying to build downstream service that may deliver other value-added service, as mentioned by Darren earlier, event-driven can be used to create business events where downstream system can tap on immediately or in futures for other value-added services. So with that, this brings us to the end of my presentations. So before we go into the Q&A sessions, we need your help. We will be starting a poll. So please help to answer the poll questions. So the poll is to understand what is preventing you from taking the event-driven microservices approach. Right.
Okay, thank you, Anson and Darren. I think while the poll is going on, we have a couple of questions from the audience. Let's start with the first question. On what basis does a business can consider a technology change from monolithic architecture to directly to an event-driven system architecture? Would you be able to share some points? I think this question can be open to both Anson and Darren.
Okay, let me take this question. So on what basis should business consider technology change from monolithic to event-driven architecture? So basically, my answer would be, so as I mentioned earlier, government is in the phase of digital transformation, and today the government are increasingly implementing system using microservices. So with this microservices architecture in place, if you are just one step away from creating an event-driven architecture, because microservices lend itself as a good use case for event-driven. So instead of taking a half step to implement microservices based on the so-called the easier way, which is the RESTful way, let us take this opportunity to actually take it one step further to start building your event-driven architecture so that you can, over time, hopefully create an event stream within your organization that you can derive new features and new business services that government services that you can provide based on some of the examples that I have given. So there's no better time, because now is the time that we are in the digital transformation phase as we move towards microservices architecture. So that would be my answer. I hope that addressed your question.
Great, I think that sounds convincing. So one more next question. I think this is the last question of the day. How to handle event template or format change without causing downtime?
Okay, let me take this question as well. So in the event-driven architecture, you stream events through your event platform, and the events that you publish on the platform can also have so-called schema registry architecture being tied to it. So the events that you post to the event stream actually gets tagged with a schema. So what the schema does is that it has versioning, it has the format, and when your events are being picked up your microservices using this particular framework, you actually can validate the schema, and when there's a version change, you can coordinate the version change using the schema registry in place that you put in place. So in short, event-driven doesn't mean that you post any message to the event stream, and hopefully the other services that pick up the event understand what this message is all about. So we have things like event schema registries to help you manage this process, the versioning as well. Yeah.
Okay, we have a few more questions coming in fast and furious. You shared the complexity of using compensation to ensure data consistency in REST implementation approach. So does that mean that there is no need for compensation in an event-driven approach? I think this is a question that's addressed to Anson.
Yep, let me take that up. So this is a good question. So in the sample scenario that's given, yes, there's no need for compensations. However, does not necessarily means that there's no compensation required for event-driven approach, right? There are scenarios where compensation is still required. However, the advantage of using this event-driven approach is that It reduces the complexities of multi-level nested compensations that I earlier mentioned by using the REST approach. And another things that I'm going to talk about is actually when there's a need for compensations, the service will just emit the compensation events back into the event streams. So that if the intended service is not available, all right, the service will just it doesn't cause the compensation to fail, right? You will just wait for the when the service recovers, you will again pick up the compensations from the event stream and do the compensations. So it's actually more reliable as compared to the REST approach, right? So there's no need to do reconciliations at the end of the day because of the data inconsistencies that may caused by the REST implementation. Hope that answered the questions.
Okay, we have one more question. In an event-driven architecture, the event stream will become a single point of failure. What can we do to mitigate this?
Okay, let me try to give an answer. So Darren may add on if you feel like. So okay, like earlier mentioned, Darren also mentions about this thing called dumb endpoint and smart pipes, right? So by doing this, we just have to actually make sure of this event streams is highly available. So we do not need to actually, instead of making sure all the various services is highly available, we just make sure that this event stream itself is actually highly available. So it ensures that there's no data loss and everything it comes and stored into this event stream itself.
Thank you, Anson. So let me just add on. So we are actually looking at an events streaming platform that is distributed and actually can be handle replication and all this. So there's no single point of failure. So the reason why companies like LinkedIn can handle 7 trillion messages a day, which I shared earlier, it's not, they can't do it without a fault-tolerant event streaming infrastructure in place. So we just have to deploy the right kind of a streaming platform for this kind of, if you are seriously building an event stream in an organization, we cannot compromise on that. We have to choose a streaming platform that is suited for this. Yeah.
I think we have addressed quite a few questions. There has been one last question that says, so what kind of solutions detailed with that? I think we will reach out to you directly, or you can drop us an email at info@topan@query.com. It's coming almost to 2 o'clock. Thank you so much for staying with us throughout the session. We really hope that you have enjoyed this session and it has been informative to you. Do remember to head over to our YouTube channel, subscribe to our channel, and do give us a big thumbs up. Thank you, everyone. Bye-bye.